We looked at Cartesian coordinates in 2 dimensions using the x and y letters to label the up and down and the left and right. But we can move to higher dimensions if we want, particularly 3 dimensions will be important. So it's just worth having a quick look at what that might look like. We would have an axis up and down, an axis left and right, and if you just imagine this in 3 dimensions, an axis that goes backwards and forwards like that. So all of these axes are at right angles to each other or perpendicular to each other. Now you'll have to imagine this really in 3 dimensions. It's usual to label the vertical axis the z-axis, the up and down axis, and the flat 2-dimensional axis we can label x and y. It doesn't really matter so long as you're consistent, so long as you know that x means left and right, y means forward and backwards, and z means up and down. You can't go wrong. And in a similar way to the 2-dimensional case, we might well have a point in 3-dimensional space called P. And to talk about the coordinate of P, we have to figure out how far along the x-axis we've gone. And then we have to specify, it's difficult to get this in 3 dimensions, we have to specify how far along the y-axis we might have to go. And then finally, how far up the z-axis we might have to go to reach that point. So if we have to go along B units in the x direction, A units in the y direction, and C units in the z direction, then the coordinate of the point P would simply be the x coordinate first, which is B, the y coordinate A, and the z coordinate C. So the coordinate of point P will be BAC. Now, one last point to note is that if we're solving a mathematical problem and we're working in 2 dimensions, let's say x and y, and we're modelling the motion of something across a plane. If we're doing this on a computer, if we want to, for example, plot a point on a computer or plot the motion of an object across the screen based on our calculations, then we have to be a little bit careful, because it might be that our coordinate system that we're using on paper to model something mathematically might be different from the way a pixel is located on a screen. And it's just something to bear in mind. I don't want to say too much about it now, but we have to bear in mind that the axes on a computer terminal, computer display, may well be different from the x and y axes that we're using to calculate and solve our mathematical model. So you'll have to account for that and be aware of that somewhere.